Is it working? Yes, it's working. So, hello everybody. Thank you for joining us to this Sub0 conference in Lisbon. I'm super excited to be here with you all. And this is Starter Space A. Welcome you all here. And I would like to introduce Brother Youssef from Web3 Foundation. Please welcome him to the stage.
All right. Hello, everyone. Thanks for coming. Is it supposed to be? I assume it's good audio. Hello, everyone. Yeah, my name is Brother Youssef. I'm a technical educator here at the Web3 Foundation. And today, I just wanted to kind of talk to you a little bit about it's titled The Complete Guide to Becoming a Substrate Developer. For some of you, that maybe this is like very obvious stuff, but you'd be surprised in how many people ask me some of these questions on really how to get involved with this technology, because there's just simply so many different components, right? There's so many moving pieces to this puzzle that it becomes hard with all the various nomenclature and everything like that. So, oops, I didn't mean to go there. So I just wanted to kind of guide you through some of those tools and kind of the meaning of why we do all this stuff in the first place. First of all, I think the most pressing term that people always mention is like Web3. We mention this all the time. I see a lot of people put it, whether it's in like their LinkedIn subtitles or their job titles, like I'm a Web3 developer. And really all that kind of means is that they're trying to work towards a web which is less about trusting people and more about building robust systems to keep people in check, right? That's all that we're trying to do. And you hear this mentioned like everywhere. Rollups are probably one of the most hottest things right now. When you hear about Web3, you either hear about smart contracts, rollups, or layer 2s. However, I just want to emphasize that there is a lot more to this space than just simply these technologies. Right, and again, this seems pretty obvious, and I'm running through these fairly quickly because it can be a bit obvious. I'm assuming everyone here pretty much knows what a blockchain is. But what does it mean to be a blockchain engineer as well? I think that's a question that's really worth exploring. And blockchains at their core, this is what they are. They're a finite, just deterministic state machine. It's a way of getting from state A to state B and then defining the rules for how to do that. Most often, it's easy amongst all the fluff of the industry to get lost in the different terminologies, but essentially, like at its bare bones, this is what a blockchain does. It does that with some cryptographic guarantees, with some game theory and economics as well, and a lot of research. And it allows us to create systems which are robustly able to handle a lot of user input and make sense of it and also apply rules to it. So, there we go. But yeah, not only are they just like state machines from state A to state B, but they're deterministic. And determinism is a pretty crucial part of this industry because it allows us to predict that if we give input X, we should get output Y as a result. So it allows us to create systems that are both secure and deterministic. It allows us to make guarantees about data if data comes in. And I always like to use the example of a vending machine as an example of this, right? A vending machine has a set of rules. If you give it a certain amount of coins, it gives you something out, which you know exactly what it's going to be each time. So in many ways, a blockchain works very, very similarly. Let's see. And then at its core, right, all of this, what does it do? It gives data integrity. With Web 2, I'm going to say Web 2, but with what we have right now, if I put a piece of data online, there's no real way for me to track the integrity of that data. There's no way for me to actually authenticate the source, where it came from, all these different things. For example, like GPT models, I don't know what GPT model, what data it may have used, what biases it may have, things like that, like context-specific data. There's no way to keep track of the integrity for it, right? So blockchain, gives us some of that capability to track things in a way which is deterministic, right? And now we're going to actually get into, so with that like very, very brief primer, let's get a little bit into the Substrate and Polkadot ecosystem, right? In my mind, I divided this up into really two categories of if you want to become like a Substrate developer or someone who works in this space, there's really two broad routes. And then within those routes, there are actually even more routes you can take and specialize in. It's a very open field for people to develop on. So the first one, and this is very much like analogous to how we have things currently, you can go into like front-end dev, right? And this is like client-side focus, more on the layer of the application. There's various like libraries and tools which you can use to build decentralized apps, or sometimes we call them unstoppable apps. We use that term in the Polkadot ecosystem. Really, it's just an application which uses Polkadot or Substrate or a blockchain to some level, right, with nothing in between. So there's nothing in between blocking that. You just have a client-side app which utilizes these Web3 services, right? And then, of course, the things that power these apps are on the protocol side, and that's where we get into smart contracts, into building blockchains, right? And Polkadot, it's actually, I think, probably one of the only ecosystems, maybe besides like Cosmos, where you can build a blockchain relatively easily because all the tools already exist, and we'll get into what tools exist, right? And exactly how you can go about doing that. But the back end of Web3 is the blockchains, it's the smart contracts. And to be very clear, blockchain is not like, I say it as if it's some holy grail. It's not the holy grail for this stuff. It's just one piece of the puzzle to get to this more robust future where we can actually track information and provide transparency into information. And this is where we get into Substrate. Now, Substrate is how you build these blockchains, right? And at its essence, it's just a framework for building these chains. It gives you all the tools and the libraries you need to build these blockchains. Right? All the moving parts. So blockchains are relatively, and these systems in general, Web3 systems in general, really require a lot of different moving parts and components. Things like networking, right? Peer-to-peer networking. You need some business logic to actually realize your solution. You need a way to store state after you've done changing it. And then, of course, you need a way to upgrade the chain or upgrade your system if you need to. And Substrate gives us something called forkless upgrades, which is very, very useful for that exact notion. Normally with a blockchain, you have to fork it, and it's a very intense process. This way, you just replace the runtime, and you can get a forkless upgrade. But we can talk more on that a little bit later. And a little bit more, really what Substrate is, it's very analogous to something like React. If you've ever used a front-end framework like React, something pretty simple. It's just a set of libraries, right, that gives you these tools. And you can kind of mix and match them as you need to build your specific solution, while still remaining compatible with perhaps other Substrate-based chains or other blockchains or even EVM, as we'll explore later. And all the hard stuff essentially is taken care of for you. Networking and consensus, block authoring, fork resolution mechanisms. Normally these things are very involved, and if you're building a blockchain from scratch, you would have to worry about creating these yourself. But luckily we get kind of these generic implementations of this functionality to kind of solve for us, so you can focus on just building the actual application that your chain is meant for. And then another thing under Substrate, which you're going to see a lot, is Cumulus. And really, Cumulus is how you build parachains. So Substrate, keep in mind up until now, I'm not talking about parachains. Parachains are used to connect to Polkadot, right? With Substrate, it doesn't have to be a parachain. You can build a solo blockchain that just does its own thing, and it's not connected to Polkadot. But if you want to build, like on Polkadot, build a parachain for Polkadot, you have to use Cumulus. And it gives you, it's essentially Substrate with some dedicated functions and extra utility used to validate with the Polkadot relay chain. So like the PVF mechanism for the parachains protocol, proof of validity blocks, all these concepts are included inside of Cumulus. So if you need to build parachains, you'd be using Cumulus, which is also using Substrate. So in a way, Substrate is encompassing all this technology, right? That's why it's called Substrate. It's a foundational layer for building chains. And you can see here there are an abundance of various libraries for Substrate. So everything from networking to pre-made runtime modules, which you can just use out of the box and mix and match them, right? And that's done using Frame, which we'll get into in just a second. But you can see here, it's things that normally you would have to make from scratch, essentially, that are just provided for you. So a wide array of tools there. This is kind of the anatomy of a Substrate node. So all the way here on the left, or I guess on your guys' right, there would be the client, right? This client, all it's responsible for is kind of propagating network changes, right? It doesn't really care about what changes they are. It's just responsible for networking with other peers and communicating via like libp2p. libp2p is used very broadly throughout this ecosystem. It's used as the primary network implementation for this stuff. And then, of course, you have the runtime. And the runtime is the one that you're probably going to be working with the most. The runtime lets you use various modules and create your chain from those modules, right? And what happens is the client calls the runtime via host functions, because the runtime is actually just a WebAssembly blob. It's just a blob of WebAssembly. You write your Rust code, it compiles to WebAssembly, and that is your runtime. So your runtime is actually this portable, shareable thing, but it doesn't it doesn't worry about networking. It just worries purely about business logic. So you would write your supply chain tracking use case inside of the runtime. You would write your specific staking mechanism inside of the runtime. And then, of course, as a very, very foundational part, you have storage. Now, storage in Substrate and in blockchain in general is something to use very, very sparingly. And in Substrate, it's something that's taken extremely seriously, right? Storage, we can't get into it now, but there's a lot of abstraction layers, Merkleized storage and everything like that to ensure integrity of these various modules. But at its very foundational level, it's a key value database, and you can store your state changes that come in from the client through the runtime. And if it actually changes something, if state A changes to state B, then that state can get updated within the storage, and then all the nodes, of course, are kept abreast of that. And then you may have heard me say frame. Now, frame is yet another part of the Substrate puzzle built using Substrate. If Substrate was React, this would be more like Angular because it's quite opinionated. You would mix and match various frame palettes to build your chain, and you can create your own frame palettes. And these are just your runtime modules, right? So you can see here I have all different types of modules, Aura, Babe, and Grandpa. These are consensus and block authoring specific modules and finalization modules. So this is really core stuff. But then, of course, I can also build things like an EVM module. So I can actually have an EVM running inside of my Substrate node and integrate that as part of my blockchain alongside all of my Substrate and Polkadot stuff. So you can see it's quite expansive in that way. And this is a brief showing on how the runtime works, because if you're a Substrate developer, probably the thing you're going to be spending the most time on is the runtime. You're going to be spending time within the runtime, which eventually compiles to WebAssembly, right? Each palette has a configuration within the runtime, so it has a set of parameters depending on who made the palette. You would configure those parameters, right? Let's say you want to configure those parameters. You would use a forkless upgrade, and then you would change the runtime code. So let's say you need to change some limits on on the staking palette, and then you want to submit that as an upgrade to the network. You can do that without having to fork it. Or let's say you want to take out the pseudo palette. Pseudo is it's exactly as it sounds. You can run any extrinsic or any transaction, provided it has the root privilege or root origin. You can choose to remove that, replace it with something else. Again, done using a forkless upgrade, right? What you're really doing here, at a very simple way of explaining it, you're simply taking that existing WASM blob and replacing it with a new one. That's all that ends up happening. The way it happens, you get to decide that, but essentially this is what happens, so that the blockchain's networking concepts, consensus concepts, things like that, they stay intact, but your actual business logic can change as you decide to change. And it's also really nice if you're developing a solution and you want to change things on the fly without having to worry about forking and stuff. You don't have to worry about it. So it's quite powerful to use. When you're developing a runtime, there are some things to keep in mind. And one of them, as I said, was storage. Now, storage is considered a scarce thing. You shouldn't be making state changes constantly. If you're having, for example, a for loop running within, inside of every block, that's obviously pretty terrible design because it costs resources to do this, right? Another thing about usually these blockchain-based systems or these distributed systems is there's usually a cost to everything, right? People can't just change state for free in most cases. So you want to use this storage wisely, because once you finalize that change, it's finalized for good, and someone will have to pay for it, right? So you have to use your storage very sparingly and really decide when you decide to make that state change. Another thing is, and I think this is obvious, is don't roll your own crypto. If you don't want to use custom cryptography, because it's the basis for all of this to be validated. You don't want to be using some custom cryptography or untrusted implementations. It should be audited. Luckily, Substrate gives some pretty good implementations of common curves and algorithms, so that's already available to you, right? And your goal is to create an infallible runtime. So you can see here the runtime is a really, really important thing, because if the runtime fails, then your chain can kind of be bricked. But in most cases, this doesn't really happen. As long as you handle errors correctly, things don't panic, and rusteds panic, or basically like a seg fault. If that doesn't happen, if you make sure to take care of all of the various use cases, and sometimes it gets really granular with the amount of errors you have to define and account for. But yeah, let's see. And of course, like I said earlier, you can have an EVM running inside of Substrate, and this is done as a frame palette. So there's this tool called Frontier, and essentially it's two palettes, actually. There's the first palette is the EVM, right, which can run Solidity smart contracts. So let's say you include this palette in your Substrate-based chain. doing all of your Polkadot stuff, Substrate stuff in your custom application, you can actually run Solidity contracts, upload and run them on your chain as well. Another thing it does is provide an Ethereum RPC implementation and like Ethereum block emulation and a way to actually validate those Ethereum transactions. And so this way, this RPC, MetaMask can talk to it, and you can actually connect to your Substrate chain using MetaMask if you wish. And on the subject of kind of smart contracts, Ink is kind of the smart contract language of the Polkadot ecosystem. So yes, you can use Solidity, but Ink is also a very, very viable way to write smart contracts. And again, it's an EDCL, so an embedded domain-specific language, right? You're writing things in Rust still, but it's compiled down to like Ink-flavored WebAssembly. And those WebAssembly blobs are essentially your contracts. And you upload those using, again, a palette. So there's a palette that manages these WASM blobs, which are your contracts. And once you upload them, you can interact them just as you would expect any contract. So this is a very good alternative or way to also create smart contracts. They're also interoperable with Solidity, so you can make calls directly to your Substrate runtime using your Ink contract, or you can make calls to your Solidity contract as well. You can use all the cool Rust tooling, Rust Analyzer, Clippy, Crates.io, all the normal IDEs. So because it's written in Rust, you don't need any special tools or linters or whatever. And because it's just compiled to WASM or WebAssembly, it makes it easy just to have like an industry standard thing, right? We're not worrying about a very proprietary piece of bytecode. We're dealing with WebAssembly at the end of the day. So it's fairly easy and fairly portable to represent across multiple systems. And then I would really say that if you want to get like on the path to developing this stuff, Ink is really good to start with because you'll find that the structure of an Ink smart contract very much mirrors and goes hand in hand with how a frame palette is built. So you can like start by building a contract, and then you build your Substrate palette, which is like a blockchain core module, right? This is a good way to kind of like guide you through that path and really get used to like the syntax and the quirks of dealing with Rust and Substrate. Which brings us into what do we need to learn, right? So as I mentioned so many times already, Rust. You need to learn Rust if you're going to be doing this. There's no way around it. And Rust was chosen, of course, for its, if you guys know about Rust already, its type safety. It's a very safe language. You can write fast code and safe code at the same time, which is a huge plus. It can be a little convoluted, and especially within Frame, you're dealing with a fairly generic code base. So things look opaque and a little bit abstract, right? But over time, you'll start to learn how this stuff works. But Rust was really chosen because it really gives you these guarantees that once your program compiles, there's a very low chance that it's just going to fail on you, right? And even if it does fail, there's going to be a very good reason for it, which you can exactly account for. And really, the mindset for this stuff in general, Web3, Substrate, whatever it is that you're developing, is to really innovate, right? And it's innovating on something small is much better than trying to tackle a very big problem. So as long as you find one small problem, maybe you write like a palette for it, and it solves something, even if it's blockchain specific, like a blockchain specific problem, that's better than trying to tackle some multi-billion-dollar industry or something like that. But yeah, having that mindset is super, super important. It's not showing here, but there was a GIF. There's this really cool dev portal by Parity where you can just kind of see everything. It's not showing here for some reason, but it's kind of like a bird's eye view of everything, all the various resources from Cumulus to Substrate to Polkadot, all the documentation for them. Because I just mentioned a bunch of stuff, but it can be a little bit hard to remember. So what has been built so far with all these tools? So what can actually be done, right? We mentioned this, and it's obviously the possibilities are kind of endless. But Polkadot itself was built using these tools. So Polkadot itself is built using Substrate, which shows you the kind of capabilities that Substrate has. So Substrate is a heterogeneous, technically it's a sharded network. I think that terminology is being kind of rendered obsolete as of late. But it's a blockchain that connects other blockchains if you really want to summarize it. But yeah, so Polkadot was built using Substrate. But there's a lot of other things that can be built too. For example, like feeless blockchains that derive economic security from Polkadot. Because Polkadot really provides economic security for parachains, so they don't have to worry about consensus or anything like that. You can build custom consensus mechanisms inside of Substrate. You can build a chain with a UTXO transaction model like Bitcoin versus an accounts model, which is most commonly used in most solutions. If you want to, again, go kind of bigger, you can build an IoT-based supply chain traceability kind of thing or solution, right? Some examples of those chains that I mentioned. There's the asset and bridge hub, and the asset hub essentially it's kind of like it's a kind of a division of labor for Polkadot. So it's some parachains, they're called system parachains with like elevated permissions that handle very specific tasks, right? So they're not bogged down by the main relay chain. So like the assets hub deals with assets, like NFTs and who knows what else, for just various assets. And then the bridges hub acts as like a gateway for bridges to be connected to it, so you can build a bridge from Ethereum to Polkadot, stuff like that. Sub0, they have a directed acrylic graph-based consensus, which gives them sub-second finality. And the cool thing about Sub0 is that they're actually not a parachain. They do have a parachain, but this blockchain itself is actually a solo chain because their finality and their consensus solution is custom and different, right? Let's see what else. And of course, there is OpenGov, which is itself how Polkadot manages governance right now. And it's kind of a decentralized form of how to, like, who gets upgraded network and when, which is done via holding referenda and voting, right? There's a lot that goes into that, but at the end of the day, it's just a series of pallets, right? It's a series of blockchain modules that they decided to implement and upgrade the network with. And then, of course, this one, and I've actually had some personal experience with developing some of this stuff. You can use, I mentioned this tool called Sub0 earlier. It was actually on the graph. This is like a Rust-based client for interacting with a Substrate-based chain. So if you wanted to, you could have a device that compiles Sub0 and then talks directly to Polkadot, or talks directly to a Substrate chain and submit sensor information or something like that, sign some transaction. That's possible as well. And yep, there's a bunch of initiatives here, and don't worry, there's a QR code on the next slide, so it gives you access to a page. But there's a Polkadot Blockchain Academy, which is an intensive, like 4 or 5 week program where basically you live and breathe Polkadot, blockchain, game theory, economics, all sorts of cool stuff. There's the Developer Heroes program. They have the booth right outside of there. We're coming up with some courses at the Web3 Foundation. So courses specifically like Rust for Substrate, and as well as learning Substrate itself. So like taking you through like, here's how, like all the things I just mentioned of like, here's what you want to do and not want to do inside of a runtime. We kind of like cover all that stuff inside of one course, as well as cover, here's the things in Rust you need to emphasize to really understand the ecosystem's code, right? And then, of course, hackathons are a great way to learn. There's Treasury-funded education initiatives, as well as on the Polkadot Wiki, I put together a starter's guide, which was what that very first graph was from, right? And here, you can go ahead and scan that to get access to all the information. But yeah, these are really like all these tools together, right, will really, I think, enable you in getting either your idea off the ground or just hobbying around as a developer, because you never know where that might take you. So I highly encourage you just check out the development resources, get a node up and running locally on your computer. It's super easy stuff to get started with. And as you dive deeper, you can the complexity increases, but the power you have over your chain and how you want to build your chain or build your protocol also increases. And yeah, that's pretty much all I have. I don't think we have time for questions, but if there are any, I will take any. But yeah, thank you for coming.
Yeah, thank you very much. My question is, if we want to build integrate custom logic into our substrate-based chain, let's say parachain, which method do you prefer? Should we choose building smart contracts, or do we need to build pallets?
That's a really good question. I think it depends on your goals and what your solution will do. So generally, the idea is a smart contract is a sandboxed environment, right? You can only do so much with a smart contract. It has limited resource constraints, stuff like that. A pallet gives you, like, think about it like unlimited power almost, right? It's almost like developing a module for like an operating system versus developing just a simple like user app. There's way more power you have with a pallet than you have with a smart contract. So it really depends on what you're trying to build and how much permission you need from the protocol itself, right?
Thank you.
Is there any question from the audience? Oh, yes, there is one more. Please.
Can you talk about the recent merge of the Substrate and Polkadot repos and how that might affect someone trying to build for the first time?
Yeah, that's a really, really good. I did not get the chance to put that in this presentation, but what happened recently was, and you're going to see if you visit these resources, Polkadot SDK mentioned everywhere. And what happened recently was that it used to be that Cumulus, Substrate, as well as Polkadot were all 3 separate repos. Now they're combined into one mono repo. So everything you'll find will be under one singular repository. It shouldn't really affect the experience too much. I personally have not found anything other than just obvious, like there's going to be some, there's going to be kind of a transition period where things might be misnamed here and there. But generally, I haven't found really too much of a difference in development experience so far, from my experience. Yeah.
Thank you.
Thank you for your question. Is there any other question?
20 seconds.
Oh, yeah, one more. The last question.
Yeah, if you are going to develop a parachain, do you have to, is there such a thing as a standard node? Or do you have to also build the node?
That's a good question. This is more of a Polkadot like architecture question, right? So when you build a parachain, you don't have to run a validator set for that parachain. It's called a collator, actually. I mean, it's kind of like a validator, but without having to have these security guarantees. And its job is to pass data from the parachain up to the relay chain. And the relay chain's validators and the validation mechanism there, that's what takes care of that validation for the parachain. But your parachain does have to have a collator, yeah, which is essentially a validator in many ways, except for the fact that it doesn't actually validate the parachain.
Yeah, but what I meant is when you, there is this Substrate parachain template, and I was surprised to see that there is a node there. I expected just to need to program a runtime.
Yeah, so obviously you can just program a runtime, but it's not really that useful unless you can put it into practice. So it gives you some like template node structure that includes some like pre-configured block authoring, some pre-configured consensus, like Aura, which is a kind of a way of selecting block authors. It's just like a round robin, super simple, so it has that. And I think it also has finality as well, grandpa finality. I forgot if that template has it. But yeah, it gives you some like basic networking just to get you up and running so you can build a runtime.
Thank you for the questions, and thank you, Youssef, for your excellent presentation.